Okay, so have you ever gotten so hungry that you just get kind of grumpy? Like even the smallest things can just set you off. You know what I mean?
Oh, yeah, totally.
I always thought it was like me just being dramatic or something. But it turns out there's actual science behind it. We're going to dive deep into that today. The whole neuroscience of hunger. And specifically, we're going to talk about these brain cells called AGRP neurons, which are like your brain's hunger alarm, basically.
Oh, wow.
We've got this really cool Korean article. I don't know if I'm going to try to pronounce the title, but it's all about these AGRP neurons, and it's just packed with insights about why we eat, even when we're not actually hungry,
That's so interesting.
So I'm excited to dig into this.
Yeah, me too.
All right. So I guess to start off, where even are these neurons in our brains?
Well, they're not just randomly scattered around. They're actually located in a really specific spot near the underside of the brain. And what's really interesting is that they're right next to the blood supply, which gives them direct access to hormones that are coming from your stomach and your fat tissue, basically giving them real-time intel on your energy reserves.
So they're like little spies in there.
Exactly, yeah.
So what happens when our energy dips? Do those neurons send up a flare or something?
Yeah, it's almost like they sound the alarm.
Yeah.
When your energy levels start to get low, these AGRP neurons just go into overdrive, and they send out signals to different parts of your brain that basically scream, "Find food now."
Wow.
And the research on this is actually pretty wild. Scientists have deactivated these neurons in mice.
Oh, really?
And you know what happens?
What?
The mice completely lose the urge to eat to the point of starvation.
Oh, wow. Okay, that's kind of scary. So just flipping a switch on these neurons can make or break our desire to eat.
Yeah, it's a pretty powerful control mechanism for sure.
That's wild.
And, on the flip side, when they artificially activate these neurons, the mice go on a total eating binge.
Yeah.
They just can't get enough food. It really just highlights how crucial these neurons are to our survival.
So, I mean, that makes me wonder if we could somehow target these neurons to treat eating disorders. But I'm guessing it's not that simple.
You're right. It's definitely not just a simple on-off switch. Research back in 2015 showed that things are a little bit more nuanced than that. They found that while AGRP activity, it increases when a mouse is hungry. It actually decreases when they simply see or smell food, especially if it's something that they really like.
Oh, interesting. So even the anticipation of a good meal can calm down those hangry neurons.
Exactly, yeah.
Your brain is saying, okay, reinforcements are on the way. We can stand down.
Exactly.
But I'm guessing there's a catch.
Well, there's a catch, yeah. This decrease in activity is only temporary if the mouse doesn't actually get to eat the food. Those AGRP neurons fire right back up, even more intensely this time.
Ugh, I can relate to that. We've all smelled those fresh baked cookies and then been so disappointed when they weren't for us.
Oh, yeah.
Such a bummer.
And speaking of tricks, researchers actually took this a step further. They gave mice calorie-free treats.
Oh, so they're messing with the mice.
Yeah. They wanted to see what would happen to those AGRP neurons when you provide the sensory experience of food, but without any of the actual nutrition.
So we're basically messing with their expectations.
Yeah, exactly.
Okay, so what happened? Did their little brains get fooled?
Initially, yeah. The mice, they ate this calorie-free gel, and their AGRP activity dropped, just as if they'd eaten real food. But get this, over time, their brains caught on.
Oh, sneaky.
They learned that this treat wasn't actually giving them any calories, and their AGRP neurons stopped responding as strongly.
So they weren't fooled for long. It seems like our brains are a lot smarter than we give them credit for. They can actually tell the difference between real food and imposters, which makes me think about all those diet foods that promise to satisfy cravings without the calories.
Oh, yeah.
So, I mean, it sounds like our brains aren't easily tricked in the long run. Just trying to mask that hunger with sensory cues. Maybe that's not a sustainable strategy for weight loss.
Yeah, it kind of hints at why diets that are focused solely on restriction often just don't work. We need to address the underlying biological drive, not just mask it,
Yeah.
And it also brings up that whole idea of mindful eating.
Oh, totally. If we actually pay attention to what we're eating and how it makes us feel, maybe we can retrain our brains. to
No.
respond more to real hunger cues rather than just those like tempting sights and smells.
Exactly.
But I'm still like curious, what's the signal that actually tells our AGRP neurons to chill out after we've eaten like real food? Is it just like a full stomach or is there something else going on?
It actually turns out the key is the calories reaching your gut, not just the feeling of fullness.
Oh.
Research from Alpidef showed that
Yeah.
it's the arrival of those calories that actually turns off those AGRP neurons for a longer period, not just the sensory experience of eating.
Okay, so it's not just about like tricking our brains with fake food or just like distracting ourselves from hunger.
Yeah.
It's about actually giving our bodies the fuel they need to shut down that alarm system.
Right.
But how does that message travel from our stomachs to our brains?
Well, that's where it gets even more interesting.
Mm.
Fat and glucose actually take different routes to signal the brain. Fat uses the vagus nerve, which is like this super highway of information running from your digestive system all the way to your brain.
Okay, so fat gets the like express lane.
Pretty much, yeah.
What about glucose?
Glucose takes a different route. It sends its signals through the spinal cord.
Wow, so our body has like different delivery trucks for different types of fuel.
Exactly.
It's like a finely tuned logistics operation going on in there.
Totally.
That's so cool. Do scientists know why we have those two distinct pathways?
That's actually still a mystery. Scientists are still researching why these multiple pathways exist, but it really highlights just how complex the system of appetite control is.
Yeah.
You know, there's this whole intricate web of signals and feedback loops that we're only beginning to really unravel.
Wow.
So we've talked a lot about how these AGRP neurons can like drive us to eat when our energy is low. But what happens when these neurons go haywire?
Oh, yeah, that's a good question. I'm like really curious about how these hunger signals might be involved in eating disorders like anorexia.
Yeah, this is where the research gets really fascinating. So people with anorexia, this intense fear of gaining weight, and they restrict their food intake, like to the point where it becomes dangerous.
Yeah.
And it's a really complex disorder with like psychological and biological components. And it seems like those AGRP neurons might actually be part of the puzzle.
So even when their bodies are like starving, their brains aren't sending out the right signals to make them eat?
Exactly.
Right.
Researchers have actually been studying this using a mouse model of anorexia. It's called activity-based anorexia, or ABA. And in this model, mice are given limited access to food and a running wheel. And some of these mice start showing these like anorexia-like symptoms.
Really?
So they eat less than they should, and they become hyperactive, running on the wheel even when they're like totally exhausted.
Wow, so it's like they're driven to exercise even when their bodies desperately need fuel?
Right.
That sounds eerily similar to what we see in humans with anorexia.
Really is, yeah. And here's the interesting part. The AGRP neurons in these ABA mice, they don't behave normally. They don't decrease their activity after the mice eat, even when they're like clearly hungry.
Wow.
So it's almost as if their brains aren't registering that they've been fed. So that drive to eat just stays suppressed.
So they have the hunger neurons, but they're not getting the message.
Right.
Oh, that's like heartbreaking. But at least it like gives us some more insight into the biological stuff that's going on with anorexia.
Right.
Is there like any hope for these mice? Can we like somehow override that faulty signaling?
Well, that's what's so exciting about this research. So scientists have actually found that by artificially activating the AGRP neurons in the ABA mice, they can actually jumpstart their appetite and help them gain weight.
No.
It's like they're giving the mice's brains a wake-up call.
Wow.
You know, like, hey, you need to eat.
That's so cool. So like there is potential there for targeting these neurons to develop new treatments for anorexia.
Yeah, it's definitely a promising avenue of research for sure. Of course, you know, human anorexia is far more complex than a mouse model.
Yeah.
But this finding at least gives us a really valuable starting point. It helps us understand the biological pathways that might be disrupted and opens up new possibilities for interventions.
That is amazing. Okay, so we've like really focused on these AGRP neurons, but they're just one part of a much larger system, right? Like there's more to appetite control than just feeling hungry.
Oh, you're absolutely right. Food seeking, which is driven by those AGRP neurons. That's just one piece of the puzzle. There are other areas of the brain that are involved in, like feeling satisfied and experiencing pleasure from food.
Okay.
And sometimes those areas can actually override the signals coming from our AGRP neurons.
So like even when we're full, there's another part of our brain that's like, but what about dessert?
Exactly. Think about it. You've just finished a huge meal. You're stuffed. But then someone brings out your favorite cake, and suddenly you have room for one more slice.
Oh, yeah.
Your AGRP neurons are telling you you're full, but those other brain regions are lighting up with anticipation and pleasure.
It's so true. So, like, how do we even begin to tackle overeating when we're, like, battling multiple brain regions? Is it even possible to target those different areas?
That's the big challenge, and that's why, weight loss has been such a difficult issue to address. We have seen some progress with medications like Wegovy, which work by acting on those AGRP neurons to suppress appetite. But these medications often come with some pretty unpleasant side effects.
Yeah.
Which just highlights how complex the system is.
Yeah, for sure. So, it's not just about finding one magic bullet that silences those hunger signals.
Right.
It's about understanding that whole symphony of brain activity and hormones and even learned behaviors that all contribute to our relationship with food.
Exactly.
It's wild.
It's about understanding how all these different systems interact and influence each other. And that's what makes this research so important. Yeah. It's not just about developing new treatments, but also about, helping us understand ourselves better, why we taste the way we do, and how we can make more informed choices.
This is giving me a whole new perspective on those times when I reach for a snack, even though I'm not actually hungry.
Yeah.
Maybe it's stress or boredom or just the fact that there's so much tempting food around us.
Right.
That hijacks those other brain regions and drowns out those I'm full signals.
Exactly. Our environment and emotions play a huge role in our eating habits.
Yeah.
And figuring out how those factors interact with our biology is really crucial for developing effective strategies for, managing our weight and our relationship with food.
This whole conversation has really made me think differently about hunger. It's not just about willpower, or making good choices. There's all this crazy stuff happening in our brains.
Right.
We're just starting to figure out, so where do we go from here? What does all this research tell us about the future of treating eating disorders? Or even just helping people manage their weight?
Well, I think the future of this research is really exciting. We're moving towards this idea of personalized medicine, where treatments for things like, overeating or anorexia could actually be tailored to your specific genetic makeup and brain activity patterns.
So, instead of this one-size-fits-all approach, we could have treatments that are, specifically designed for you.
Exactly.
That sounds straight out of a sci-fi movie.
It does. But it's closer than you might think. I mean, we're already seeing the beginnings of this with genetic testing and brain imaging techniques.
Oh, wow.
And as we learn more about these AGRP neurons and how they interact with other appetite-regulating pathways, we'll be able to develop more targeted and effective therapies.
That is amazing. But I gotta admit, it also makes me a little, nervous. If we can manipulate these hunger pathways, couldn't this technology be, misused?
Yeah.
What's to stop someone from, creating addictive foods or even controlling people's eating habits without them knowing?
I mean, that's a totally valid concern. And it's why it's so important to have these open and honest conversations about the ethical implications of this research.
Yeah.
With any powerful tool, there's always the potential for misuse.
Yeah, that's true.
That's why we need, clear ethical guidelines and regulations to make sure that these discoveries are used responsibly for the benefit of humanity.
It's a good reminder that scientific advancements always come with this responsibility to think about the potential consequences, both good and bad.
Right.
It's not just about the science itself, but how we as a society choose to use that knowledge.
Exactly.
Wow.
It's a conversation that needs to involve everyone. Scientists, policymakers, ethicists, and the public. We need to be mindful of the potential downsides while also embracing those, amazing opportunities that this research offers.
For improving human health and well-being.
Exactly, yeah.
Okay, well, this has been a seriously fascinating deep dive into the world of hunger. We've gone from those tiny AGRP neurons to the big picture stuff, treating eating disorders and the ethics of it all. It's been quite a journey. Is there one key takeaway you'd want to leave our listeners with?
I think the most important takeaway is that, your relationship with food is way more complex than you probably realize. It's not just a matter of willpower or making good versus bad choices. There's this whole intricate web of biological factors at play. And understanding those factors can really empower you to make more informed decisions about your eating habits and your health.
That's such a good point. It's it takes the pressure off of blaming yourself for those late night cravings
Yeah,
or that extra slice of cake, you know?
exactly.
It's about recognizing that there are these powerful things happening in our bodies and that you can learn to work with your body, not against it.
I love that.
So yeah, the next time you feel that pang of hunger, just take a second to think about all the amazing stuff happening in your brain and all the science that's helping us understand it all better. Thanks for joining us on this deep dive into the science of hunger.